Hello everyone, welcome back to our channel JIB and CIB Made Simple, where we simplify complex topic for CIB exam make success. Today we are diving into the world of measure of central tendency. Don't worry if it sounds complicated at first. We are going to break it down into simple, easy to understand language. So before beginning, this is the topic measure of central tendency and dispersion, skewness and kurtosis. So first of all, let me show you what are the topic which we are going to study. Yes, so now you can see the first topic is introduction to measure of central tendency, arithmetic mean, combined arithmetic mean, geometric mean, harmonic mean, medians and quartile, mode, introduction to measure of dispersion, range and coefficient of range, quartile deviation and coefficient of quartile deviation, standard deviation and coefficient of variation, skewness and kurtosis. So basically I think there are 10 to 11 topic which we are going to discuss. So this will be covered in 2 to 3 videos part wise, right? So we will cover the first one, then second one. So let's start with the first one. So friends, imagine you have a huge jar of candies. So first of all, my question is, what is the measure of central tendency? What is the meaning of this term? So for that, suppose there is a jar, right? There is a jar of candies, right? And you want to know on average how many candies each type has. Sorry, there is a jar of candles or candies. Let's take candies. There is a jar of candies, right? There is a huge jar of candies and you want to know on average how many candies each type has. Rather than counting every single candy, you can use something called a measure of central tendency. This is just a fancy term for a single number that sum up a large amount of data. So we can say this is a fancy term for a single number that sum up a large amount of data, making it easier to compare and understand the overall picture. So the question is, when data is neatly organized, either classified into groups or arranged in table, we can use a statistical tool to crunch the number, isn't it? When it is neatly organized, either you have a table or you have a groups, so you can use the statistical tools to crunch the number. Two of the most common tool, right? You know that two of the most common tool are the measure of central tendency. Let me highlight it. So what are the tools which we use? The first is the measure of central tendency, here it is, and the second is dispersion. You can see central tendency and the dispersion. These are the two measure tool used. So today we are focusing on the first one because it helps us reduce a mountain of number into a simple representative value. So basically we have a mountain of number, right? Large quantity of data, and we, through this tool, we can reduce the data to a single value, single representative value. So here are the two big reasons we use measure of central tendency. What are the two main objectives of using the measure of central tendency? So we will discuss the dispersion in the latter part of the lecture. First of all, let's focus our attention on the measure of central tendency. So what are the two reasons why we use the measure of central tendency? The first reason is the condensing data. Let me write it down. The first reason is condensing data. You know about condensing data? Let's see. So instead of shifting through tons of number, you get one clear value that tells you the middle or average of your data. So there is single value, one value that tells you what middle or the average of your data. And second thing is that it facilitates comparison. That means it makes the comparison easier, right? You know it very well that it becomes easier to compare different set of data because you are working with just one number for each set. Two things I am talking about. First objective of central tendency measure is the condensing data. Second objective is that facilitate comparison. Comparison means become easier to compare different set of data because you are working with just one number for each set, right? Because suppose this is a huge lot of data, right? This is data set 1, this is data set 2. Instead of all this data, you take only one data. Instead of all this data, you take only one data, and in this case you also take one data. You can easily compare these two, right? Because you have just single set of data. So that is how it facilitates comparison, and obviously it helps in condensing the data because you condense the entire amount of data in a single value. So these are the two main objectives of the measure of central tendency. Think of it like comparing two classroom test score, right? So suppose there are two classroom. Let me give you example to give you more perspective. So there is two classroom, right? And test you have conducted, and you are comparing the test score of two classroom. So instead of looking at every student score, you compare their class average. What you do? You find class average of first class, you find class average of second class, and you compare them. right? So this is what we call as this is how it works. So what makes a good measure? Okay, so now we know that how it is helpful, we know the objectives of the good central tendency. Now the next pertinent question is what, let me just write it, what makes a good measure? What makes a good measure, right? So now not just any number will do, you know it very well, not just any number will do. A good measure of central tendency needs to have few key qualities. So here we are focusing on what are the key qualities, right? We are focusing on what are the key qualities of a good central tendency. So first thing is that it should be clearly defined. Here you can see rigidly defined. It means that it should be very specific, so there is no confusion about what it represents. Second point is that simple and easy. You can see simple word and easy word. What it means that both in terms of understanding and calculation it should be simple. Second point is that it should be inclusive. Third point, not I think the third point, it should be inclusive. What is the meaning of this term inclusive? See, it must take all observation into account. You can see all observation of the data should be taken into account. And the fourth point, you can see it should be mathematically feasible. Let me write it down. Mathematically it should be feasible. What it means? It means that you should be able to use it in further calculation if needed. That is called mathematical feasibility. That means you should be able to use it in further calculation. Then the last is it should be stable. It should be stable. What it means? It should not change much even if you take different sample, right? That is called stability. So let me again revise. Rigidly defined, that means it should be clearly defined, simple and easy, inclusive, mathematically feasible, stable. These are the key requisite for a good measure of central tendency. And the next point you have, it should be unduly affected, means it should be resistance to the extreme value. What it means? That outliers. So this is super important. You know, if this question was asked, what is the meaning of outlier? You know outlier, those unusually high or low number shouldn't skew it too much. That is called outlier. Outlier should not skew it too much. That means I am talking about measure of central tendency. The central tendency should be such a number that does not get affected by these outliers. That is what I am telling you. And the last feature is that it should be easy to interpret. Ultimately, you should quickly grasp what the number is telling you. In short, we can say a good measure of central tendency is like a reliable friend. You know, reliable friend, right? Clear, consistent, trustworthy, no matter what the situation is, right? So that is the essence of measure of central tendency in nutshell. So understanding this basic will help you make sense of data, whether you are comparing financial figure or analyzing exam score, right? I hope this make you concept clear. Now let's talk about the three types of average, which is super important. So we are diving deeper into the world of average, the secret ingredient that help us understand the data better. When we talk about average, we are really talking about the three main types: mean, median and mode. But let's start with the superstar of average, which we call as mean. Mean is the superstar of average. So mean, or simply average, whatever we call it, is the most popular way to describe a bunch of number with just one number. You know, you have a bunch of number and you want to describe it just single number, and that is where mean comes into play. Think of it as a middle ground. You can think of it just wait a minute. You can think of it like a middle ground. You know, middle ground. You can think of it like a middle ground, right? That represent your entire data set. And guess what? These are actually three different kinds of mean. As you can see, let me tell you: arithmetic mean, geometric mean and harmonic mean. Today we are focusing on one thing, that is arithmetic mean. So calculating the calculating the arithmetic mean is super simple. Imagine you have a set of number. First you add all those number up, and then you divide the total by the number of item in your list. First you add all the number, right? Number 1, number 2, number 3. Suppose you have 4 number, you added them and divide by the number in your list. So there are 4 numbers, so divided by 4. So it is like sharing a pizza equally among your friend. The total pizza is divided by the number of people, isn't it? For example, let me give you example to make it more clear. For example, if your test score are suppose 70, 80, 90, right? And you add them together. So just add them, 70 plus 80 plus 90, this will give you 240, right? And divided by 3, because 3 numbers are there, so that give you average score of 80. So the mean is valuable because it gives us a quick snapshot of our data, right? It gives us a quick snapshot of our data, whether you are comparing exam score, tracking expenses or analyzing financial trend. Knowing the average help you understand what is normal and what things compare and how things compare to that standard. And that is arithmetic mean in a nutshell. Single, effective, super useful, right? So now so there are different kinds of data that we have to go through as, right? So the first type of data is that arithmetic mean of ungrouped or raw data. So first let's talk about the ungrouped and raw data first. Okay, so how to calculate the ungrouped or raw data? So suppose you have x1, x2, x3 dot 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 xn. There are n observation of x. What we do? We summarize summation of I is equal to 1 to I is equal to n. It is equal to x1 plus x2 plus x3 plus x4, right? When I say summation, it means what? X1, put I is equal to 1, you will get x1. Put I is equal to 2, you will get x2. Put I is equal to 3, x3 plus x4 plus x5 plus dot 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 plus xn, right? So this is the summation of all the x, and divided it all by n. N is what? N is the number of observation. For example, you can see here that 10 students are there, that marks is given 35, 30, 18, 15. You see these marks, and arithmetic mean is given 30. Find the value of x. How to find the value of x? Quite simple. What you do, you just what is the mean? 30. Mean is 30, and how many students are there? 10. So what will be the total value? Total will be how much? 30 into 10, isn't it? This will be 300. Now you may ask me why we have multiplied both of them. Quite simple to understand. X bar is the mean, is equal to summation of xi divided by n. So if we want to find the summation of xi, we can't do like this. Can we do like this? We can do it. We multiply the average by n, and average here is 30. Arithmetic means the average, and n is the 10 because 10 students are there. So summation of xi, I get 300. And what are our xi? It is nothing but 30, 18 plus 15 plus 40 plus 32 plus 52 plus 47 plus 10 plus x is equal to 300, isn't it? You add all of them. After addition, you will get 277 plus x is equal to 300. So x will be how much? 300 minus 277. This will give us how much? 23. This is a kind of linear equation which you can frame. Just you have to remember the key formula here, right? Just you have to remember the key formula here. What is the key formula? You can see this is the key formula you have to remember. That's all, right? So this is how you should go about solving such type of problem. So this is the case of ungrouped data or raw data that we call it, the raw figure which we call it. Now what about the group data? Instead of ungrouped data, suppose we have a group data, then what to do? How to go about solving the case of the group data? Let's talk about it. Quite simple to understand. What do you know the difference between group data and ungrouped data? Like in the previous case, we just write down the number, that was ungrouped data. But if we talk about the group data, so there is something in the form of tabular format. You know it very well. So it is divided into two columns. On the left side you will see on the right side you will see the frequency, on the left side you will see the variable, isn't it? So suppose there is a variate x which takes value like xi, x1, x2, x3, x4, x5, and corresponding frequency is f1, f2, f3, f4, f5. This is the case of group frequency. We already know this grouping and ungrouping in the first lecture, in the unit 1. We know it about it, right? So if the variate takes value x1, x2, x3 till xn with corresponding frequency f1, f2, f3 till fn, then how to find the arithmetic mean? What you do, you create another column. Which is multiplication of these two columns. So say it is column 1, say it is column 2. So you create xi fi column. So what will be the first element? x1 f1. Second element x2 f2. Third element x3 f3. Fourth element x4 f4. Fifth element x5 f5. Now what you do, you add all of these. So can't we write it like this? Summation of xi fi divided by summation of fi and divided by the sum of it. This will you get. I will provide you example to make it more clear. So this is the classical formula for calculating the arithmetic mean of a group data. Summation of xi fi, I is equal to 1 to I is equal to n upon summation of fi, right? Now one more thing you should remember. What are these xi? Xi are the class mark of the class interval for group continuous distribution. Yes, this you have to remember. That since we have a group data, and the group data is represented in this format like 10 to 20. Now you may ask me a question that if this is the case, which value to take? Then you have to take the class mark. You know what is class mark? It is the middle value, which is 15. You have to take. Like suppose this is the case. Let me give you an example to make it more clear to you. So suppose you have this case like this. 5 to 10 frequency is 30, 10 to 15 frequency is 20, 15 to 20 frequency is 30. Like suppose 20 to 25 frequency is 25. So this is our case of xi, and this is the case of fi. So this you can see is the kind of group frequency. Now which single number should I take? So we should take the class mark. Like the class mark in this case will be 7.5, in this case will be 12.5. If you don't know about what is class mark, please go to unit number 1 theory lecture. I have provided the concept of what is the class mark. Class mark is a single number which represent the middle of that particular range, right? So class interval, you can call it class interval to be more precise. So this xi are the class mark, right, of that interval, and fi you know frequency. Like you can see here, you have to find the arithmetic mean of this number. How to go about doing it? Let me talk about it. So let me show it. So what you do, you prepare a table. Simply you prepare a table. Okay, so you prepare 3 columns. The first column is regarding x, second column is regarding f, third column is x into f, right? So what are the values? What is x? 1 2 3 4 5 6 7 and 8. Corresponding to one frequency is 5, corresponding to frequency is 6 5. Just I am noting down 10 8 4 3 2. Now 1 multiplied by 5, let me use different color here. 1 multiplied by 5 it will be 5, 2 multiplied by 6 it will be 12, 3 multiplied by 5 it will be 15, 4 into 10 it will be, sorry, I think it is 4, right? Yeah, 4 multiplied by 10 it will be 40, 5 multiplied by 8 it will be 40, 6 multiplied by 4 it will be 24, 7 multiplied by 3 it will be 21, 8 multiplied by 2 it will be 16. Now what you do, you add all these, 5 plus 12 plus 15 plus 40 plus 40, 24, 21, 26, you will get 173. And you add all these, 5 plus 6 plus 5 plus 10 plus 8 plus 4 plus 3 plus 2, you will get 43. And this division will give you the arithmetic mean. Is it clear now? How to go about solving the arithmetic mean of a group data? This is how you have to do it. You just prepare a table, you just prepare another column with xi, fi, right, and you will get it. Like in this case, in this particular case, you can see you have to calculate the arithmetic mean. How to go about doing it? Let me show you. So first of all, what you will do, you will create a table, right? Instead of 3, I will suggest that you create 4 column, because you know there is a class interval here, right? So first let's write it down here. So here what I do, that this is the class interval, this is class mark, this is f frequency, and this is the multiplication. You can call it x, f into x. Okay, now what is the class interval? 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and finally 80 to 90. I don't have a space for that. No, not worry, just understand the basic concept which we have to do. Now you know what is the class mark of this class interval? 25. What is class mark of this class interval? 35, 45, 55, 65, 75, and the last one is 85, isn't it? That is what I am talking about. In this particular case, when the grouping is like this, you have to take the class mark, that is xi hour. And what are the frequency? 5, 12, this one, 5, 12, 10, these are the frequency, right? 14, 5, 8 and 4 here. Now what you need to do, you need to multiply the xi into fi. 25 into 5 will give you 125. 35 into 12, calculate it how much you are getting. I think you will get 70 multiplied by 6, which is 420. Then 45 into 10 you will get 450. 55 into 4, 55 into 14, which is 110 into 7, that is 770, right? Then you have to do 65 into 5. So how much you will get? 60 into 5, 300, 25, 325. 75 into 8, that is 150 into 4, that is 600. And 85 into 4, this is the last one, which is 170 into 2, that is 340. Now what you do, you add all of them, 125 plus 420 plus 450, 77, this will all of them, you will get 3030. And you add 5 plus 2, this frequency, 5 plus 2, this one, we are talking about this, 5 plus 12 plus 10 plus 40, you add all, you will get 58. Just divide it and you will get the mean, that is 52.24. And the third question is for you, you do it yourself, right? Third question is for you, you solve it yourself. Let's continue studying combined arithmetic mean. So let's understand what is the meaning of this combined arithmetic mean, right? So suppose we have 2 samples. Okay, suppose we have 2 samples. So this is the first sample and this is the second sample. Okay, and suppose the size of this sample is n1. the first sample size is n1 and the second sample size is n2, right? And suppose the arithmetic mean of the first sample, this is called first sample, this is called second sample. The arithmetic mean of first sample is x1 bar and the arithmetic mean of second sample is x2 bar. Okay, now we want to find the combined arithmetic mean of the distribution, right? So how we can find the combined arithmetic mean? So you might have heard about the weighted average, right? You know how to calculate the weighted average? Simply you multiply this n1 with x1. So we can write n1 x1 bar plus n2 x2 bar divided by n1 plus n2. This will give you the combined arithmetic mean x bar, right? So again I am repeating, for first sample having size n1, mean is x1 bar, for second sample having size n2, mean is x2 bar, right? So the combined arithmetic mean of the distribution can be given as n1 x1 bar plus n2 x2 bar upon n1 plus n2. This will give you the combined mean, right? So just you have to remember this formula, quite simple to understand. Let us solve some numerical to reinforce the formula in our mind. So let's solve the first numerical that we have. The average marks of a group of 100 students. Let me show you what is the question. So there are 100 students, right? In mathematics are 60, and for other group of 50 students, the average marks are 90. So suppose this is the first group. Let me change the color here. Just wait a minute. Okay, I will use suppose this color. Okay, so this is the first group having 100 students and the average is given 60. This is the second group having 50 students and the average is given 90. You have to find the combined group average mark of 150 students. How to go about doing it? Simply you multiply this 100 with 60. 100 into 60. You multiply this 50 to 90. So 50 multiplied by 90. Add both of them. So 100 into 60 plus 50 into 90. Right, so this will give you, I think it is 6000 plus 4500 upon divided by n1 plus n2, 100 plus 1. Total how many students are there? 150. So this will give you how much? 70. After you add, you add and you will see you will get 70, right? So this is how we go about calculating the average marks of a group of a student, right? Combined average. I hope this make your concept clear. Now let's go to the next example. In a private health club, there are 200 members, right? So the first sample is regarding the men. 100 men are there, 80 women are there, and 20 children are there, right? So these are the 3 samples we have. It might be possible that 4 sample, 5 sample may be there, no issue. And for 100 men, the average weight is given 60 kg. For 80 women, average weight is 50 kg. For 20 children, average weight is 35 kg. And you have to find the average weight of the combined group. So what you do? You multiply this 100 with 60. You multiply this 80 with 50. You multiply this 20 with 35. And you add all of them and divide by total. Total is how much? 200. So divide by 200, right? So after addition, let's see, 60 times 1000 will give you 6000 plus 80 times 500, 80 times 50 will give you how much? 4000. I think it will give you 400. No, 4000. Yes, it will give you 4000. And then 20 times 35, this will give you how much? 700. So after you add them, you will get how much? 11,700. Oh, sorry, 10,700 divided by how much? 200. So after the calculation, you will get the average weight as 53.5. I hope this makes the concept clear, right? I'm explaining it step by step. Now let's see the third question that we have. An average daily wage of all the 90 worker, you can see average daily wage of all the 90 worker in a factory is 60. The average daily worker of female worker is 45. Calculate the average daily worker of male worker if 1/3 are male. So what is happening here? See, this is the, suppose this represent male, this represent female, and after combining this represent the whole group. Okay, so this is total how many worker are there? 90 worker are there, and average is given 60. Okay, now average daily wage of female, so this is female worker, average is given 45, right? And given that 1/3 are male, if 1/3 worker are male, right, so 2/3 will be female. So suppose x number of worker are there, x is the total number of worker, right? And number of worker is provided to you, 90 worker, right? So 1/3 are male, clearly written, 1/3 are male. So how many are male? So 30 will be the male and 60 will be the female. So you have to find the average daily worker, average of the daily work. So you have to find this one. Suppose it is x. Suppose x is the average of the average average wage of the male worker. So what you do? 30 multiplied by x, 30x, 60 multiplied by 45, how much you will get? 60 multiplied by 45, so it clearly means 90 multiplied by 30, 2700, and 60 multiplied by 90, you will get 5400, isn't it? So what you do just now, you just write the equation 30x plus 2700 is equal to 5400, or we can solve this equation 30x is equal to 2700, or x is equal to 90. So x means the wages of average wage of man worker is rupees 90, right? So I hope it is clear now how to go about finding the average daily wage of male worker. Just you have to apply the logic, just you have to apply the formula, right? So this is all about the example number 7. Now let's see the example number 8. Let's see how to go about calculating example number of 8. So it says that mean of 25 observation was found to be 78.4, but later on it was found that 96 was misread as 69. Find the corrected mean. Okay, how to go about solving it? So 25 observation was there and mean was found to be 78.4. So let's say the observation was x1 plus x2 plus x3 plus dot plus xn divided by 25 x25, we can say x25. This was how much? 78.4. okay. So later on it was found that 96 was misread as 69. What happened? That it was written 96, but here you have taken 69. So suppose x3 you take as 69, but you should have taken 96. You should have taken 96. So find the corrected means. So you have to just find the corrected means. So how to go about finding the corrected means? So what is happening here, that raised number are equal, raised number are the same, but this instead of this 69 you are taking 90, instead of 96 you are taking 69. So obviously mean will increase. Mean will obviously increase. So first of all, what you do, you calculate the total sum. You calculate summation of xi, which will be how much? 25 multiplied by 78.4. This will give you 1960. So this is the sum, right? This is the total sum, isn't it? And you know that after you, what is the difference between 96 and 69? The difference is that, just let's calculate it. So it will give you 7 9 16 and 8 6 27. So you add this 27, right? That is the total. So you add this 27. So this will give you how much? 1987. So this is the correct sum, because what you did earlier, that you put here 69, but you should have put here 96, right? So the earlier, the wrong sum was 1960, the correct sum is 1987, because if you put 96 the sum will be higher, isn't it? So the correct sum is 1987. So now you know the sum of all the number is 1987, and how many number are there? The number are 25. So divide 1987 by 25. This will give you 79.48, which is the correct mean, right? So whenever such question is asked, what you do, you find the sum, and you see that instead of 69 we write 96, our sum will obviously increase. So find the increased sum, find the correct sum, and divide it by number to get the corrected mean. I hope this makes the concept clear. So one more question for you to solve. You can see the mean salary of 50 employee was 680 rupees per month. Later it was found that salary of Mr. X was taken 270 instead of 720. So what is the corrected mean salary? So again you do the same thing. You find the wrong sum. You find the wrong sum. So how to find the wrong sum? So simply multiply the mean with the, okay, so mean is given, mean of 50 employee was computed with itna, right? So just multiply 680 multiplied by 50. So this will be how much? This will be 340 multiplied by 100. This will be how much? 34,000, isn't it? So this is the wrong sum. Now what will be the correct sum? So correct sum, what is happening here, that we are taking the salary of one person as 270. We should have taken 720. So what is the difference? 720 minus 270, how much it is? I think it is 550 or 450. I think it is 450, right? Yes, 450. So you add this 450 to this. So this will give you how much? 34450. This is the correct sum, and now you have got the correct sum. Just divide it by 50. Just divide it by 50. You will get the correct mean salary. That is what we have done here. Let me show you. Right. Just wait a minute. Yeah, here it is. So 34450 divided by 50, you will get 689, which is our correct mean. So this way you should go about calculating the corrected mean. So I hope this example give you a clear insight on how to go about dealing with the arithmetic mean, right? So these examples are sufficient. Now let's discuss the what are the merits of arithmetic mean. Let's discuss the merits of arithmetic mean. So the merits of arithmetic mean is that it is rigidly defined, it is easy to calculate and simple to follow, it is based on all the observation, it is determined for almost every kind of data, it is finite and indefinite, it is readily put to algebraic treatment. These are the merits of arithmetic mean. You can easily calculate mean, it is based on all the observation, right? For every kind of data you can determine the mean. Obviously it is finite and indefinite. So these are the merits, but there are demerits also. Like you can see, for by extreme value it is highly affected by the extreme values. It cannot average the ratio and percentage properly. It is not appropriate average for highly skewed distribution. So suppose your distribution is highly skewed on one side, right? So it is not appropriate there. It cannot be computed accurately if any item is missing. The mean sometimes does not coincide with any of the observed value. Mean cannot be calculated when open-ended class interval are present in the data. Sometimes it happens that open-ended class interval, you know about it, open-ended class interval. There are two kind of class interval, close-ended and open-ended, right? Suppose I write below 25. I write that data like below 25, the height, suppose this is 25 represent number of person, right, or age, below 25 year of age, the height is 60. And I write between 26 to 30, between 25 to 30 age, the height is suppose 70, or 6 inch and 7 inch, 6 feet and 7 feet, suppose I write feet and inch. So how do we calculate mean here? It's not possible to calculate mean here, right? So whenever we have open-ended class interval, you know, like when I write 20 to 30, so it is a close-ended. We calculate the class mark and then calculate the mean. Okay, it's okay. But if we have open-ended class interval, it is quite impossible to calculate the mean. So that is their limitation here. It cannot be used to calculate the mean of the open-ended class interval. Second thing is that mean sometimes do not coincide with observed value. Obviously it is possible. Then we have, it cannot be computed accurately if any item is missing, right? It is not an appropriate average for highly skewed distribution. So these are the demerits of arithmetic mean. We should know about it. Now let's talk about the geometric mean now. What is geometric mean? It is also, you know, this is also a measure of central tendency. So this is the average value or mean which measures the central tendency of a set of number by taking the root of the product of their value. So what you do? So while you have the values, right, you find their product. Suppose you have value x1, x2, x3. So you find their product multiplied by x4, multiplied by x5, and take the root, right? So what do? You first multiply them and take the root of the product of the value. So this is what we call as geometric mean of a set of data, right? Is it clear? So you must remember this, I have highlighted here, that geometric mean is always less than the arithmetic mean. So we can say GM is always less than AM, remember it. And geometric mean is calculated only for positive value. It is not calculated for negative value. It is always done for the positive value. Please remember these two things, very very important. Right. So what is the application of geometric mean? So application is that it is used in stock indices. You can see it is used in stock indices. Then it is used to calculate the annual return on portfolio. So you have to calculate the annual return on portfolio. The geometric mean is help you. It is used in finance to find the average growth rate, which are also referred to as the compounded annual growth rate. You might have heard of this CAGR, compounded annual growth rate. So in finance, the geometric mean is used to calculate CAGR. It is used in studies like cell division and bacterial growth. So stock indices, annual return, CAGR, right, cell division and bacterial growth. So these are the places where this our geometric mean is used. Furthermore, you can see some more application here. Now let's talk about how to calculate the geometric mean of ungrouped data and grouped data. So first of all, let's talk about the ungrouped data. So ungrouped data geometric mean calculation is quite easy. Just you multiply all the observation and take under root 1 by n, right? So you can either write in this way, that under root n x1 x2 dot xn, or we can write like this, x1 x2 x3 dot xn divided by 1 by n. So you can write either of the way, doesn't matter. So let me give you an example to make it more clear. The first example, you can see you have to find the GM of the value 10, 24, 15 and 32. So what you do first, multiply both of them, multiply all of them, 10 into 24 into 15 into 32, and you take 1 by 4 because 4 number are there, 1 2 3 4. So you take under root 4, right? Either you write this or you write like this, both means the same, both means the same. So if you calculate, you will get 18.423. So I hope this make your concept clear, right? I hope this make your concept clear how to go about calculating the GM of the values. Now, so these were the ungrouped data. The data was not group 1, but now suppose we have a group data, then how to go about calculating it? So let me explain how to go about calculating the GM of a group data. So when I say group data, it means every group data can be written in this format. You know it very well that we can draw a table, and on left side I will write the observation, and on the right side I will write the frequency. So xi, fi. Okay, so for first observation x1 we have frequency f1, for second observation x2 we have frequency f2, for third observation x3 we have frequency f3, for fourth observation x4 we have frequency f4. Now what you do, you create another column, right, which is multiplication of both. So xi, fi. So x1 f1, x2 f2, x3 f3. Suppose we have 4 data, x4 f4. Is it clear? Now what you do that no, just wait a minute. This was done for arithmetic mean. Here we are telling geometric mean. Just wait a minute. No need to draw this particular table. Let me erase it. No need of it. Okay, so now what you do to find the geometric mean of this ungrouped data, what you do, you write x1 and you put power f1, you write x2, you put power f2, you write x3, you put power f3, you write x4, put power f4, and take under root n times. Or we can also write it, you write x1 f1, x1 to the power f1, x2 to the power f2, x3 to the power f3, x4 to the power f4, whole divided by 1 by n. Either you write power 1 by n or you write under root, both means the same. What is n here? N is the number of observation. What is x1? x1, x2, x3 are the observations, and what is f1, f2, f3, f4? These are the frequencies, right? So let me give you an example to make this concept more clear. Let us take an example here. So friends, here you can see you have a group data. This is the example of the group data. You can see a table has been provided. X value have been given. For 1 frequency is 5, for 2 frequency is 6, for 3 frequency is 5, for 4 frequency is 10. How to go about doing it? So 1 to the power 5, 2 to the power 6, 3 to the power 5, 4 to the power 10, and divided by 1, or we can say, just wait a minute, no need to write like this, and don't take under root, divided by how many numbers are there, divided by what is n? N is the sum of all of them, right? N is the f1. So remember, what is n? F1 plus f2 plus f3 plus f4 plus fn. So what is f1 here? 5 plus 6 plus 5 plus 10. So this will be how much? 11 plus 5, 16, 16 plus 10, 26. So for this you have to use the calculator. You can't do it manually, right? You have to use the calculator, because 1 to the power 5 will be 1, right? So 1 to the power 5 will be 1, but from these three you have to calculate it, and after calculation you will get something like this, 24705. That is the GM for all this data. So I hope this make your concept clear how to go about calculating the GM. Right, now let's talk about the merit of GM and demerit of GM. Of geometric mean, if you want to construct the index number, then geometric mean is quite useful. Then it is not affected much by the fluctuation of sampling. We have talked about the sampling, and if your sampling fluctuate, geometric mean does not get affected much, and obviously it is based on all the observations. So these are the merit, but there are some demerit also, that it cannot be easily understood, and obviously it is relatively difficult to compute, as it requires some special knowledge of logarithm. Obviously you have to use logarithm also, right? You must have heard of log. So it cannot be calculated when any item or value is 0 or negative. Suppose I take a 0 value, and if you multiply anything with 0, it will come, final result will be 0 only. So if one of the sample or one of the value is 0, you cannot use the geometric mean. And what about negative? Why negative is not done? So let's see. Suppose I take two value. One value is 2, another value is -3. You multiply both of them, you will get negative. And you know, under root negative is not defined. Clearly you know that we can't take a square root or under root of any negative value. That is why if our value is 0 or if our value is negative, this geometric mean does not work. So this is one of the major demerit. Arithmetic mean work, right? But in the case of geometric mean, we can't take any negative value. So this is the relative demerit of it. And obviously you need knowledge of logarithm, and also you know demerit is that it cannot be easily understood. So these are the merits and demerits. Everything, every coin has a two sides, right? Now let's talk about the harmonic mean. What is the meaning? In the definition of harmonic mean, you can say reciprocal of arithmetic mean of reciprocal of the observation. First of all, what we do, we have the observation, right? Then what we take, we do the reciprocal of them. You know what is the meaning of reciprocal? Let me explain you. First of all, you have the observation, you take their reciprocal, and then you find their mean, and then again you take the reciprocal. So this is all about how do you calculate reciprocal harmonic mean. Let me give you an example. Suppose we have three observation, x1, x2 and x3. First of all, what you say, take reciprocal. When I say reciprocal, it means dividing by 1. So for x1 it will be 1 upon x1, for x2 it will be 1 upon x2, for x3 it will be 1 upon x3. So this is the first step. We have to take the reciprocal. Then we have to calculate their mean. Mean, you know how to calculate. So for mean, what we do, we just add them, 1 by x1 plus 1 by x2 plus 1 by x3. We just add them and divide by their number. How many number are there? 3. So this is the second step. And the third step is again we take the reciprocal. So for x, the reciprocal is 1 by x. For a by b, reciprocal is b by a. Similarly, you have to reverse it. Whatever is numerator, it become denominator. Whatever is denominator, it become numerator. So likewise, for this particular number, we are talking about this one. Let me highlight this one. For this particular number, if you want to take reciprocal, so 3 will come at the top, and 1 by x1 plus 1 by x2 plus 1 by x3 will go at the bottom. So this is what I mean when I say harmonic mean. Is it clear? We have the observation, first we take the reciprocal, then we take the mean, and then again we take the reciprocal, and then we will get harmonic mean. Is it clear? So it is a 3-step process. First take the reciprocal, find the mean, and again take the reciprocal, right? So this is called harmonic mean. You know, harmonic mean is used to calculate the average of ratios or rates. Application, it is used in finance to find average of different rate. It can be used to calculate quantities such as speed, because you know a speed is expressed as a ratio. Whenever something is expressed as a ratio, harmonic mean is the best way to find the central tendency, right? This you must remember. Now let's do some application part, let's do some calculation part here. So how to find the harmonic mean of ungrouped raw data? So for ungrouped raw data, the formula is simple. Divide n, I is equal 1 by xi, I is equal to 1 to I is equal to n, right? What is n here? N here is the number of observation of x, like x1, x2, x3, x4 till xn. Suppose n observation are there, so n is the number of observation. So you just put number of observation in the numerator and divide it by summation of 1 upon xi, I is equal to 1 to I is equal to n, right? So let me give you one example to make this concept more clear. Suppose you have 4 value, 10, 24, 15 and 32, and you want to find their HM. HM is harmonic mean. What you do? You write the number of observation, that is 4, in the numerator, and in the denominator you write 1 upon 10, you write 1 upon 24, you write 1 upon 15, or you write 1 upon 32. This you have to do. So this is the first way of doing it. Another way is that what you do, you first of all find the reciprocal, like reciprocal of 10 is 1 upon 10, reciprocal of 24 is 1 upon 24, reciprocal of 15 is 1 upon 15, reciprocal of 32 is 1 upon 32. You find their mean. How to find their mean? Divide by 4, and then you take the reciprocal. Both means the same. Either you go about first method or second method. This is how you find arithmetic mean, and after the calculation you will get 16.6945. Obviously you have to use calculator here to be fast. So for ungrouped data, the harmonic mean calculation is quite simple. What about the group data? So for group data, what we need to do, the only thing you need to remember is that replace this 1 by fi. Like you can see, the formula become n is the same. In the numerator you have to just write n, but in the denominator it will be fi by xi, I is equal to 1 to I is equal to n, right? And what is n here? N is the sum of frequency. Already we know it, f1 plus f2 plus f3 plus dot plus fn, right? In every case, either in arithmetic mean, geometric mean and harmonic mean, a small n is always the sum of frequency, as we know it very well, like we done in the previous mean also. Is it clear? So let me give you one example to make it more clear. So here it is. You can see this is a group data. Let me show you. Just wait a minute. Yeah, you can see this is the case of the group data. So this is the case of group data. So for these are xi, x1 is 1. Just wait a minute, let me change the color. So x1 is 1, x2 is 2, x3 is 3, x4 is 4, f1 is 5, f2 is 6, f3 is 5, f4 is 10. So x1, f1, you know it very well. So what you do, you just write 4. How many number of so what is n here? N. So let me show you what it is all about. So first thing first is to find the n. The first thing you have to do is to find the value of n. Right, how to find the value of n? N is equal to f1 plus f2 plus f3 plus f4. What is f1? 5 plus 6 plus 5 plus 10. This will be 26. So n is 26, right? So in numerator we will write 26. In numerator we will write what? 26. So 26 divided by what? Divided by what? Fi upon xi. Fi is 5 upon 1 plus 6 upon 2 plus 5 upon 3 plus 10 upon 4. So just calculate it, you will get 2.137. So you just remember the formula and no need to remember it. You just understand the meaning of harmonic mean. That's all. So now we know what is AM, what is GM, what is HM. Now let's compare. You know that arithmetic mean is approximate if the values have the same unit. Right? If suppose value are having the same unit, then arithmetic mean is appropriate. So when arithmetic mean is appropriate, when the values are having the same unit. Like suppose you are comparing kilometer, then you can use. You are comparing speed, that is ratio. Okay. So main thing is that values are having same unit. Whereas geometric mean is appropriate if the value are having different unit. And harmonic mean is appropriate if the data value are ratio of two variable with different measures called rate. So whenever we deal with rate, remember harmonic mean is the best thing to do. And whenever the units are having same unit, whenever the values are having the same unit, then arithmetic mean, you should go about arithmetic mean. And whenever we are dealing with two different units, then geometric mean work the best. So this thing you have to remember that AM is always greater than HM, arithmetic mean value will be greater than HM, and this will be greater than GM. This order you have to remember, right? So first AM comes, AM is larger, then HM comes, and then GM comes, GM as the last. And one more formula you have to remember, super important formula, that is what? AM multiplied by HM is equal to GM square. Okay, so let me give you an example to make it more clear. So you have to find the harmonic mean of two number A and B if their arithmetic mean is 16 and geometric mean is 8. This question is asked every year, so remember this formula, super important. So how to find the harmonic mean of two number? Arithmetic mean is given 16 and geometric mean is 8. You know the formula, AM times HM is equal to GM square. So AM is how much? 16. HM you don't know, suppose it is X, and GM is how much? 8 square. So X will be how much? 64 upon 16, which will be how much? 4. So answer will be HM will be 4. So you remember, whenever for two data, right, or three data or number of data, AM is given, HM is given, and you need to find GM. If out of any three, 2 is given, out of any three, 2 is given, you need to find the 3. You can apply this formula. This formula work well, right? AM into HM is equal to GM square, right? Now let's talk about the next central tendency measure we have. It is regarding the medians and quartiles. First let's discuss the median. You know what is the meaning of median? Median, as the name itself suggests, it is the middle value of a distribution. You have a distribution, you have to find the middle value, and that is what we call median. You know, median of a distribution is the value of the variable which divides it into two equal parts. So we have a distribution. Suppose this is the distribution, these are the points, each every point distribution. You find a middle point which divides the entire observation in two different parts, two different equal parts. Here the keyword is two equal parts. This is the keyword. You find at that particular point which divides our distribution in two equal parts, and this particular point is what we call as the median. So you find that value which divide our observation in two equal parts. Keyword is equal parts. So median is a position average, whereas the arithmetic mean is calculated average. That's the difference between median and average. Suppose someone asks you, what is the difference between median is also a measure of central tendency and arithmetic mean is also a measure of central tendency? What is the difference? The difference is that median is a position average, because I am again telling you that suppose this line represent the observation. You find a position which divides our data into equal parts. That we do in median, but in the case of arithmetic mean we calculate the average, right? That's the difference. Okay, so let me make more conceptual clarity about median. So I think there's quartile also. So let's understand quartile also. What does quartile do? Let's try to understand. It represents division of data into 4 equal parts. Quartile, you might have heard about this term, that a quarter, you know, 1/4. So what we do, suppose we have this data distribution, we divide into 4 equal part, 1 2. So now you can see first part, second part, third part, fourth part. So first, second interval are based on the data value, and third they are relative to the total set of observation. So the quartile divide data into 3 points. The Q1 is the lowest quartile, median is the Q2, and the upper quartile is the Q3. To create 4 data set grouping, you can see we have 4 data set. This is data set 1, this is data set 2, this is data set 3, and this is data set 4. So the interquartile range is a measure of variability around the median, which is calculated using quartile, and quartile are denoted by Q1, Q2, and Q3. You must know it. Q1, Q3, and Q3 are the notation. So let me show you using a normal distribution curve. You know this is a normal distribution curve, right? It is a bell-shaped curve. You know it very well. Okay. Now you can see what is happening here. This is the midpoint. This is that particular point which divides into 2 equal parts, right? It divides it into 2 equal parts. On the left, you can see this particular line divides the entire normal curve into 2 equal parts. So this is what we call as the median. You know, definition of median itself says that particular point which divide distribution into 2 equal parts. So this is called median, or we can say it's 50th percentile. Is it clear now? So the area on the left of it is 50%, and in area on the right of it is 50%, isn't it? Completely dividing the area into 2 equal parts. Now the second part is this is the smallest value. This is called minimum. This is the largest value, which is called maximum, or we can call it 100th percentile. Now there is something at this point, as you can see, this line divides this particular area, means the left region, this area, into 2 equal parts. This is 25%, this is 25%. So this is called the first quartile, right, which divides the first half portion into 2 equal parts. And this particular line or this particular point divides this area, that is the right area, into 2 equal parts. So this is called the third quartile. So you know, this is the first quartile, which is called Q1. This is the second quartile. Second quartile is always median, you know it very well. And the third quartile is called Q3, which is called 70th percentile. So using this graph, you can understand clearly what is the meaning of Q1, Q2, and Q3, right? So Q1 first quartile, Q2 which is median, Q3 third quartile, and the interquartile range is Q3 minus Q1. You should also know this parameter, interquartile range, Q3 minus Q1, right? Okay, now let's find how to find the median of ungrouped data and grouped data. So for ungrouped data or raw data, there are 2 formula. The first formula, it depends on whether the number of data is odd or even. How many observations are there, whether the number of observation is odd or even. So first let's take into account odd number of observation. So if the total number of observation is odd, the formula is n plus 1 by 2th observation. For example, let's say we have taken 5 observation, like 9, 10, 11, 12, and 13, right? So this is the number of, you see the number of observation, 1 2 3 4 5. 5 is odd, so 5 number of observation is there. So what you have to do, 5 plus 1 upon 2th observation. So first of all, you have to arrange in ascending order, right? So first of all, you have to arrange in ascending order, like, so 5 plus 1 upon 2th means what? 5 plus 1 is 6, 6 upon 2 is third, right? 5 plus 1 upon 2 means third number. What is the third number? 11. So 11 is our median, right? So if the total number of observation is odd, the formula is 5 plus 1 upon 2th. That means third observation. Third observation is 11, right? So this is what we call as median. So this is all about the median of odd number of observation. What about the median of even number of observation? So for even number of observation, suppose the number of observation is even, right? So the median, the formula to calculate the median is quite simple. What you have to do, you have to find the n by 2th observation plus n plus 1 by 2th observation divided by 2, right? So let us take an example to make it more clear. Suppose we have suppose we have 6 observation: 11, 12, 13, 14, 15 and 16. You count how much it is: 1, 2, 3, 4, 5, 6. Okay, so n is equal to 6 here. So what is 6 by 2? 6 by 2 is third. So what is the third observation? That is our 13. And n plus 1 by 2th, which is 6 plus 1 by 2th. Right. So basically what you have to do, you have to find the mean between these two. Right. So 13 plus 14 divided by 2, which will be 13.5 in this case. So let us take two example here to make these two formula clear. So first of all, you have to find the median of this value. First of all, you count it: 1, 2, 3, 4, 5, 6, 7, 8, 9. How many are there? 4, 5, 6, 9 observations are there, and you have to first arrange them in ascending order. This is super important thing. Most of the time we forget it, but you have to arrange in ascending order. So after arranging in ascending order, you will get like this. Now you count the number: 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are there. 9 is odd. So what you have to do? 9 plus 1 upon 2th observation, which is 10 upon which is the 5th observation. You have to take the 5th observation. What is the 5th observation here? So you can see the 5th observation here is number 32, right? So 5th observation is, sorry, let me again count. I think it here n is 10, not 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm getting only 9. How it is taking 10? Okay, let me see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think there is some mistake in this calculation, because you see that the number of observation is odd. So for odd, we can just write n plus 1 by 2th, which is the 5th observation. What is the 5th observation here? 1, 2, 3, 4. This one. So 32 is the answer, right? So there is some mistake here, I think, in this question. Now, like you can see this, let's see the second question. Here is clearly written 10 worker. So n is clearly 10. So since this is even, what you have to do? Right. So since this is even, so what you have to do? So even, for even, you have to find the n by 2th. So what is n by 2th? First of all, you should arrange in ascending order. This is the ascending order. So n means n is 10. So 5 plus n plus 1 by 2th. So 5 plus 1 by 2, which is 6th. So you have to take the mean of 5th and 6th observation. What is the 5th observation? The 5th observation you can see is 15. And what is the 6th observation? You can see is 17. So 15 plus 17 divided by 2, which will give you how much? 16. So median will be 16. Is it clear how to go about finding the median of group data? Right. Now for ungrouped data, we have talked about the median of finding the median of ungrouped data. For finding the median of group data, we will discuss in the next session, because it is a little bit complicated formula. We will discuss every part of this formula in the next session. So that's all for today. Let's